Hello everyone. Today we are here to discuss the very important topic of power system protection, which is busbar protection. In this discussion, we will cover the following contents. We will be starting with some introductions of busbar, then what is busbar protection system, what is need for busbar protection, what is essential and desirable features of busbar protection, what is the various causes for bus zone faults, and different busbar protection schemes. Under these schemes, we will study about the frame leakage protection or fault bus protection and differential protection. Differential protection is basically there are two types of circulating current differential protection and voltage differential protection. Now let us start with some introduction of bus bar. The bus bars in electric power station and substations are the one of the most vital elements. Although with the advent of modern design methods, the probability of occurrence of fault has been reduced to negligible, but if a fault occurs on a bus bar, considerable damage and disruption of supply will occur unless some form of quick acting automatic protection is provided for isolation of the faulty bus bar. The bus bar protection is responsible for protecting the panel associates electrical apparatus such as circuit breakers, instrument transformers, and other heavy equipments. Then what is basically bus bar protection? Bus bar protection scheme aims to protect the whole bus of a switch yard by tripping off all the associated bays in case of fault in a bus itself, without waiting for tripping from other end, backward looking protection, and thereby ensure faster clearance of the bus fault. Bus bar protection basically needs some special type of attention because of the some different regions. The regions will be maybe the fault level at bus bars is very high. The fault on the bus bar would result in wide supply interruption. The system stability is adversely affected by fault in bus zone, and in the event of fault on any section of the bus bar, all the circuit equipments connected to that section must be tripped out to give complete isolation in shortest possible time. This possible time may be 60 milliseconds, this is simply for example, or lesser time, so that damage is avoided to the installation due to heating of conductors. Internal bus faults are less frequent than line fault, so we need to more attentive for bus bar protection systems. What is need for bus bar protection? Basically, I earlier told the bus bar protection is rare, but if this fault is occurs in our power system, the considerable damage and disruption of supply will occur. So, in absence of bus bar protection, fault clearance takes place more time because the fault clearance will be take place in zone second of distance relay by remote in tripping. This means slow and unselective tripping and widespread blackout with commercial implications. And the effect of delayed clearance is the greater damage of fault point, chance of failure of current transformer and other collateral damages, shock to connected costlier equipments like generators, transformer, which is earlier said in slides. Now the important thing is that what will be the desirable feature of bus bar protection scheme or bus bar protective device. When we are using bus bar protection scheme or bus bar protective device, what we think what will be the features of this type of schemes or devices. So most important feature is that high speed operation. That means when we use the protective devices, this device must be capable to operate in less than 3 cycles. Stability for external faults. That means whenever the fault is occurs outside the protective zone, that is basically called external fault, at that fault period our system must be stable. No operation due to power swings or current transformer saturation. We know that the current transformer at higher current, their iron core will be saturated. At that particular instant when the iron core will be saturated, at that particular time our protective scheme or protective device must be not operated. Discrimination between fault in its protected section and fault elsewhere. Second, same point. Discrimination means our protective scheme or protective device must be intelligent to discriminate the fault is occurs in either protective zone or outside the protected zone. That means if any external fault is occurs, then at that particular case our protection system must be not operated. Separate control of trip circuit of each circuit breaker. Main and check protection to ensure the isolation only when desirable. Not auto reclosure, no single pole tripping of circuit breaker bus fault. This is the best desirable features must have to our bus bar protection scheme or bus bar protective device. Some experts are of the opinion that the local bus protection should not be provided and the bus faults cleared by the backup relays at the neighboring stations, as the provision of the local bus protection would certainly increase the risk of inadvertent tripping. So we will most careful for this type of features of bus bar protective devices. Now next topic is what is the basic causes for bus zone faults. So according to statistical information, the majority of the faults are basically single phase in nature and temporary in character. And the causes of this type of faults are basically the failure of support insulator, flashover across support insulator, faulty operations performed by the attending personnel, foreign objects accidentally falling across the bus bars, and failure of circuit breakers to interrupt fault current or failure to clear under through fault current. That means circuit breaker will be not operate properly. These are the basic causes for bus zone faults. The clearing of a bus fault requires the opening of all the circuits branching from the faulty bus or bus section. Now the important point is that what is the most commonly used scheme for bus zone protection, which is most reliable. So the commonly used bus protection scheme will be frame leakage protection scheme, differential protection scheme, and impedance, high or low impedance relay protection scheme. Now we will started with frame leakage protection, which is also known as fault bus protection. It is one of the most simple form of protection and is applicable to small size switch gear. This method consists of insulating the bus supporting structure and its switch gear from ground, interconnecting all the framework, circuit breaker tank, and providing a single ground connection through a current transformers that connect an overcurrent relay as shown in figure. Sometimes an impedance is connected in the earth connection to limit the short circuit current during line to earth fault. Also, it is necessary to isolate the switchgear framework from lead cable, cable boxes, and other things so that when a leakage to the framework occurs, the only path for the leakage current is through the connection from the framework to earth. Now we understand the figure of frame leakage protection. In this figure, the metal supporting structure or fault bus is grounded through a current transformer. This is grounded through a current transformer, and the secondary of a current transformer is connected with the overcurrent relay. Under normal working condition, the relay remains inoperative, but fault involving a connection between a conductor and grounded supporting structure will result in current flow to ground through the fault bus, causing the relay to operate. That means when fault occurs in structure or in bus bar, the fault current will be flow through the current transformer to the grounded path, and when the current flow through the secondary of current transformer, the current will be also flow through the overcurrent relay. When the current flow through the relay, the contacts will be closed, and when the contacts will be closed of overcurrent relay, they send the information to the circuit breaker, and circuit breaker tripping the circuits and isolate the healthy section from the faulty section. Now this one is the another systematic diagram of from leakage protection scheme. In this frame leakage protection scheme, the bus bars are supplied from a power transformer. This is the power transformer, star connected power transformer secondary winding, which is supplied to the bus bar. The main difference between the previous frame leakage protection and this frame leakage protection scheme is that here we can use two types of relay, which is leakage relay and check relay. Now we can see here the secondary of power transformer, which is in star connection, is connected to the current transformer. The secondary of the current transformer is connected to the coil of check relay, and the another current transformer, secondary of current transformer, is connected to the leakage relay. Now it is seen here, it is obvious that the multi-contact relay, this is check relay and leakage relay, is energized only when both the leakage and check relay contacts are close. That is, there is an earth fault within the protected zone. When the earth voltage occurs in the protected zone, the contacts of the frame leakage relay and check relay are close. When these two contacts are close, then the contacts of this trip circuit is closed. When this contact of circuit breaker trip relay is closed, then it gives the information to the trip circuit, and circuit breaker trip the all circuit breakers and isolate the healthy section to the faulty section. But when the fault occurs outward from the protective zone, that means external fault condition, at that particular case the earth leakage current will pass through only the earthed secondary of power transformer, and the check relay contacts will close, not the frame leakage relay. Only check relay contacts will be closed in this case, but the frame leakage relay contacts will not close, and thus multi-contact trip relay will not operate. Fault bus protection is more favorable to indoor than to outdoor installations. Now next one is differential protection scheme. For the main bus bars in the power station, due to their importance in the operating condition, it is required that the disconnection be without any delay in the case of faults. Hence, it is imperative to use a differential current protection without time delay. This type of protection scheme is used for both types of fault, that is face-to-face fault and for the ground fault. This protection scheme is based on basically simple circulating current principle, which uses the principle of Kirchhoff's current law. Under normal operating condition or under external fault condition, the sum of currents entering into a bus bar will be equal to the sum of currents leaving the bus bar. In case the sum of these currents is not zero, it must be due to a short circuit, either a ground fault or face-to-face fault. Hence, due to this, we can say that this scheme will be best suitable for the face-to-face fault and for the ground fault. We can see here there are 6 circuit breakers, 6 current transformer secondary windings and their respective currents, which is I1 to I6. The relay will be connected here to operate when the fault occurs in the protective section. Now here we can see that under normal operating conditions, summation of I equal to 0, that means the current incoming the bus bar or the current outgoing the bus bar will be equal. Their vector sum will be equal. At that particular case, no current will be flow through the relay and hence remains hence relay remains inoperative. When under fault condition that means protective fault occurs in protective zone. Under fault condition, the sum of currents is not equal to 0, that is the sum value other than 0. This value is known as fault current value, and this current is known as unbalanced current. The unbalanced current flows through the relay and the relay operates in this case. The summation current of the current transformer flows through the operating coils of the relay. The current flow through the relay coils indicates the short circuit current present on the secondary of the CT. Thus, the relay sends the signal to the circuit breakers to open the contacts. There are some drawbacks of this scheme. The main drawback of this overcurrent protection scheme is the difference in the magnetic conditions of the iron core current transformers, which may cause false operation of the relay at the time of an external fault. Even with identical CTs having large iron cores to avoid the saturation with maximum fault currents, the DC transient components creates problem due to its slow decay. To overcome this type of drawbacks, we will use the voltage differential protection scheme. This scheme is basically use the linear coupler, which overcomes the difficulties of iron core current transformers. In this scheme, current transformer without iron core, which is earlier known as linear coupler, are employed so that they have a much larger number of secondary turns than an iron core current transformer. In this scheme, secondary windings of current transformers are connected together in series and the differential relay coil connected across them. The intelligent property of linear coupler is its secondary voltage is proportional to the primary current. Under normal operating condition or external fault condition, the sum of voltage induced in the secondary winding, which is directly proportional to the primary current, is 0. But in the event of an internal fault on the bus bar, the voltages of the current transformers in all source circuits add to cause the flow of current through the secondary windings, and the differential relay operate and it sends the signal to the circuit breaker and circuit breaker trips the circuits. This is the basically voltage differential protection scheme used over the current protection scheme. Now, what is the conclusion of the discussion of this type of protection scheme? That the busbar protection is an important part of the power system as the system voltage has been increasing and short circuit capacities are building up, and due to this short circuit capacities there are more chances to damage the heavily and costly equipments associated with the power system, as we discussed in earlier slides. So it is not advisable to leave the bus bar unprotected on a primary basis. So we need to protect the bus bar and make attention regarding the bus bar protection. Thank you very much.